Hi friends, welcome to my channel. This is Syed Reshma Sharif. In this video lecture today we are going to discuss about a practical voltage source. This practical voltage source is little bit different from an ideal voltage source. For this practical voltage source I am going to take a small circuit. Let us take a small circuit in which here the resistor is connected in series with a voltage. Okay, it is a simple voltage source along with a small resistor which is connected in series. It is a practical voltage source. Isn't it? For this source I am going to connect a load resistor RL. This is a load resistor RL which will give rise to a voltage VL across this load resistor. Now because of this resistance which is in series with a load, now because of this resistance there is some drop across this RAC, and this drop is given rise to a voltage across this resistor is nothing but VRSE is equal to load here there is a load current. Okay, it will give rise to a load current IL into RSC, and this IL value is given as a voltage across the load resistor. This IL value is given as a voltage. IL value will give rises a voltage across the load resistor. It is divided by IL is equal to VL by RL. This IL is given as a voltage across VL divided by RL and its values. Suppose I want to plot a graph between VL and RL. VL versus RL. It will be this is the load current IL, this is voltage VL, which I can say that the VI characteristics of the practical voltage source is added by given ideal voltage. It will be a simple constant value determined by V. Once again I am saying, listen, the VI characteristics of a practical voltage source is added by giving ideal voltage source. It will give a simple constant value V. This value is a simple constant. The value of V is constant. Okay. But now because of this load resistance, the resistance connected in series with the voltage won't be fixed. Because of this load resistance RL which is connected in series with the voltage VL, it won't be fixed. Okay, it won't be fixed. It will be a dropping in the form of there will be a some kind of dropping. Okay, the voltage will be dropped. This dropped voltage is not be fixed. It depends upon the values of RSC as well as IL, load current. I have to write a simple equation. I can say that the voltage across the load resistor, that will be VL is equal to V minus IL RSC. Here the voltage drop across these will be IL RSC. This voltage depends upon this load current as well as series resistance. So depending upon these values, RSC and IL, RSC, IL, it will be, the voltage will be dropped across series resistor. Because of that, I cannot say VL will be same as V. It will be V minus IL RSC. VL is not same as V because of some drop. So the VL is equal to V minus IL RSC. So there is a small difference between ideal voltage source and a practical voltage source. The difference is its resistor. So ideally, the RSC value is 0. So that I can say VL is equal to V. RSC is equal to 0. So this VL is equal to V minus IL into 0. That is VL is equal to V. But practically it is not possible. Practically it is not possible because every voltage source and every battery will have some small resistance which is connected in series with a voltage source. It is very difficult, okay, to avoid RSC. There is some, no, RSC is very small. Practically RSC is very small. It always be there, but ideally it will be 0. Okay, ideally it will be 0. While we are solving a problem for source transformation, we always deal with a practical voltage source, and with this practical voltage source we take RSC values very small. Ideally it may be 0, but practically there is a small RSC value will be very small. Okay, for solving a problems, we have to convert it into a current source so that we will see in practically the small values can be converted into ideally, so that we can take RSC value is 0. Okay, thank you friends. If you have any doubts regarding this, can comment me on my comment section.